Hey everybody, this brief video is going to just help you out with making sense of two-way tables just through another example. So you can watch this after you've watched the lecture and before you start your practice assignment for this unit, but let's go ahead and get to it. So here's our prompt. A random sample of 415 children aged 9 to 17 from the UK and US were asked a bunch of superhero questions, or superpower questions rather. And each student, we found out their country of origin and which superpower they preferred. So we have two variables, the country of origin, which is describing these two columns, and then the superpower, which is going to be describing these 5 rows. So 2 values for country, 2 values for superpower, but either way we've got 2 different variables. Now, one of the things with the two-way table that we're going to generally want to have first and foremost is our totals. So find the totals for each row, find the totals for each column, and when you add up all of your totals for the columns and add up all the totals for the rows, they should add up to our sample size or the table total 415. So that's a quick way to double check. And we'll go ahead and do that now. Alright, so as you can see, we do have 200 people from the UK that were asked and 215. Adding those up gives us 415. The 99 people that said they wanted to fly plus the 96 for freezing time, 67, 43, and 110 respectively for the other superpowers give us 415. So everything checks out there. So if you don't have your totals, make sure you get them. That's one of the first things that you want to make sure you do. Now we want to use the two-way table to calculate the marginal distribution. So a marginal distribution is just going to be in one of these two margins, either the bottom one or the one on the far right. And what we know about marginal distributions is we are essentially taking these two variables and we're ignoring one of them. Okay, we're turning it into the stuff that we did back in unit number 1. So which margin are we going to be paying attention to? Well, that's superpower preferences, which means that's the ones in this far right column. We're looking at all of those row totals. So we need to make sure that we put out our list of each superpower, because this distribution should be made up of 5 different options. And I'll abbreviate here just for brevity. But what we want to remember here is that every one of these is going to have the same denominator. It's out of the total. We don't care about what the country of origin is in this setting when we're talking about the marginal distribution of superpowers. So everything's going to be out of 415. Now we just need to use the row totals for each one. Okay, next we are going to go ahead and actually do the division. So this first one, 99 out of 415, using my calculator, I'm not just doing this in my head, it's roughly like 0.2385 something something. I may have gotten a decimal wrong here or there, but we're going around that to 1 decimal place. Or I'm sorry, no decimal place. We'll just go ahead and write that as a percentage because that's how it asks, and we'll write it to the nearest whole number percentage, and that's going to be 24%. Okay, so let's go ahead and do that for these remaining ones. This is just simple calculator work, so we'll zoom. Okay, and there we go. Now what you should notice here is that all of these will add up to 100% or 1 if you were adding them all together. Okay, now when you're working with percentages and you're starting to do lots of rounding, you may incur some rounding error, and sometimes your percentages won't add up to 100%. They might add up to 101 or 99%, and that's okay. Nobody's going to begrudge you of that. You just want to make sure that you are aware that it should add up to 100%. Alright, now to make a graph of the marginal distribution, again, that's not a big deal. We're going to zoom through that because this is all stuff that you have done before. Let's get to it. Alright, and there we have it. Here's our bar chart representing this marginal distribution. Again, this is nothing new. This is stuff you did in your categorical data project. All you're doing is creating yourself a bar chart for representing the variable of interest, which was superpower. You're making sure that your scales or your axes are labeled and scaled. We have titles everywhere. Since I abbreviated everything, I did give a key, and then I described what I saw. What do I see? Flight, freezing time, and telepathy were the most popular superpowers. Now, why did I not give telepathy that moniker and saying it is definitely the most popular? Well, they're they're not that far off from each other. It's the 3% difference might be considered negligible, so it's not too big of a deal, right? They're pretty close to each other. But super strength was definitely the least popular, down at 10%. Okay, now let's get into the new stuff, actually finding the conditional distribution of superpower preference among students from the UK and from the US. So to find conditional distribution, we need to figure out, well, what is our condition? What's our denominator? Which is the one that's going to be at the bottom of our fraction? Now, interestingly, at this point in your textbook, and some of the answers to your homework questions that came from our textbook don't really specify which one is supposed to be the condition you're going to pay attention to. In truth be told, when we're talking about association and relationships between two variables, it's actually not going to matter what your condition is. But I want to try and train you at this point and give you some guidance as to what you want to be looking for. Is you want to look for this key word. There's one keyword that when we talk about conditional distributions and conditional probability, it's going to be huge, and that is this word of. Of indicates the condition. This indicates, like, what's the first variable we're going to consider. And that tells me that this is going to be the denominator of my fraction when I end up calculating all my percentages to make my bar chart. And then I can also say that that's going to be the thing that's going to go on the x-axis. If you can get your head wrapped around this word of representing the condition for conditional probability when we get into that in Unit 4, it's going to be a lot easier. Now, in this case, our condition is superpower preference. So find the conditional distribution of superpower preference among those from the UK and the US. So what we're ultimately going to do is look at flight. For of those students that said flight was their preferred superpower, were they more likely to come from the UK or the US? That's what we'll do. So we need to go back up and take a look at our data table and see how many total people were there in each of these superpower categories. 99, 96, 67, 43, and 110. These are going to represent my denominators that I'm going to look at for each one of the respective flights. And then the numerator is going to be made up out of the values inside the cell. So those are going to be my numerators. Okay, let's get to it. Okay, now that I have each of my percentages of the superpower preference from which country they are from, we can go ahead and make a graph of this data. So this is going to be a side-by-side bar chart. You could also make a segmented bar chart where they stack on top of each other. That's a little bit more time consuming. It's a little bit more difficult for us to do. So instead, what we're going to do is we are going to set on the x-axis, just like we had before, each superpower. But now what we're going to do is we're going to account for the second variable. And I'm going to make a key. Now you can do different colors. I don't care how you want to do the key. But I'm going to say shaded in values are going to be for the UK and solid white are going to be for the US. Now I'm going to have to change the scale on my y-axis because it looks like I need to be able to go all the way up to at least 60. Make sure I've got titles for everything. And now what we're going to do is we're actually going to have two bars at each tick mark. Okay, so I will have the UK at 55% and then the US at 45% for flight, because I had 55% of the UK respondents say they wanted to be able to fly, but only 45% of the US respondents that said flight were from the US. That's what we should say. Of those that said flight, 55% were from the UK, 45% were from the US. So what that tells me is that somebody is more, if I know that they're going to choose flight as their superpower, they are more likely to be from the UK than they are from the US. So let's do this now. Let's finish up this bar chart. We'll do it quickly for the remainder. Alright, so here's my bar chart that illuminates a little bit the relationships between the different superpower preferences and the country of origin of these students. And a couple of things that we can look at here to try and answer this ultimate question is, are these two variables associated? Does knowing somebody's superpower preference help me determine what country they're from? Well, I can look at these first two and notice that it's not a 50-50 split, right? So if I know somebody chooses flight or freezing time, I would say they're more likely to be from the UK. But if somebody chooses invisibility, super strength, or telepathy, I would say they would be more likely to be from the US. Now you might also argue that it's not that much of a difference between a lot of these, but especially this one, at least telepathy, that's the biggest difference that we can see, right? We can see that somebody is considerably more likely to be from the US if their preferred superpower is telepathy. And that's what's going to give us a hint about association. So let's go ahead and write out a statement that kind of summarizes all of that to say, is there an association between country of origin and superpower preference? Alright, to summarize everything that we have just looked at with this very basic study, it seems that these two things are associated. If a student chose flight or freezing time, they were more likely to be from the UK than the US. You'll notice that I scratched out that phrase would be. Would be implies something happening in the future that hasn't happened yet. That's what we call inference. And we're not there yet. We're not making inference. All we're doing is analyzing data that has already been collected, and we're using it to describe the sample. We're not making inference about the population yet. Okay? So they were more likely to be from the UK than the US, while if they chose invisibility or telepathy, and to a smaller extent super strength, and I said smaller extent because that was the closest percentage group that we had, there wasn't as much of a difference, really it was 3 people, it wasn't very much, they were more likely to be from the US than the UK. Alright? Here you can see the full extent of the description there. Feel free to pause the video if you need to be able to copy all of that down. But otherwise, this example should get you through to the practice assignment for Unit 2, Lecture 1. Thanks for watching. Good luck. Have a great day.